Alright, you're most welcome. Last time we looked at calculating relative formula mass as far as molar concept is concerned. Today we also want to look at another part, that is conversion of masses to moles. Provided the mass of a chemical compound, how can you convert it to moles? So that's what we want to look at today. In this case, our new heading is in this case, if you want to convert the masses to moles, you have to remember the relationship that relates the mass and the moles, which says that always one mole of any substance is equivalent to its relative molecular mass. Or in terms of mass, 1 mole of a chemical substance weighs its RFM, or relative formula mass, or relative molecular mass, or it can be molar mass. That's what we are talking about in this case. We always say 1 mole of a substance weighs, 1 mole of a substance weighs the RFM. If you don't say RFM, then we shall talk about relative molecular mass. That is according to 1 mole of a substance. For example, mole, 1 mole of calcium weighs 40 grams, because that is the relative atomic mass of calcium. So 1 mole of any substance weighs its RFM. Let us have a sample question in this case, and it's what we are talking about. Calculate the number of moles in the following. Part A, 0.2 grams of calcium carbonate. Part B, 0.5 grams of calcium. Then part C, 5 grams of sodium carbonate. So class, we are saying that we want to look at these ones in order to bring up the concept that we are talking about as converting mass to moles. And in this case, we are saying that using the relationship which say that 1 mole of any substance weighs its RFM, and we have given an example in particular. For example, 1 mole of calcium weighs 40, because 40 the relative atomic mass of calcium. If it is magnesium, which is 24, 1 mole of magnesium weighs 24. If it is the calcium carbonate, of which we calculated the relative molecular mass, relative formula mass of calcium carbonate when it was almost 100. So if it is 100, we can say that 1 mole of calcium carbonate weighs 100. So these are the ones that we want to calculate at the moment, and we bring up the concept that we are talking about. Make sure you have written these ones, because very soon we shall erase them off, like that we can have space for you to calculate. So we are going to have calculate the number of moles in the following. Part A, we are saying that 0.2 grams of calcium carbonate. Then part B, 0.5 grams of calcium. Then part C, we have 5 grams of sodium carbonate. So we have been given 0.2 grams of calcium carbonate. We have 0.5 grams of calcium, and then we also have 5 grams of sodium carbonate. We have 0.2 grams of calcium carbonate. So having 0.2 grams of calcium carbonate, we shall first of all, if we want to convert the mass to moles, the provided mass is we are taking it to moles, then we shall first remember that the RFM first, RFM of calcium carbonate, we shall know that calcium equals 40 times 1 calcium atom plus 12 times 1, then plus 16, which is for oxygen, times 3. So this is 40 plus 12 plus 48. So in the due process, we are getting 100. We are getting 100. Now, after getting the RFM of calcium carbonate is the one that which helps us to get the number of moles. The relationship is that 1 mole of a substance weighs the RFM. That's the relationship. But for proper calculation, let us always make sure that what we have been provided with, we put it on the left. Because we are going to use first principles. Then what we have not been given, the one we are looking for, we put it on the right. Now, what are we looking for? We are looking for number of moles, meaning we have been given the what? The mass. We shall be given the mass this side. Instead of saying 1 mole of calcium carbonate weighs 100, we shall say 100 grams of calcium carbonate are contained in 1 mole. 100 grams of calcium carbonate are contained in 1 mole. Then what about the 0.2 grams of calcium carbonate that we are talking about? What about 0.2 grams of calcium carbonate are contained? So we shall get this 0.2. We multiply by 1, then we divide with this one that is here. Divide by 1 what? 100. The answer we get 3 moles. So in this case, if you try to divide this, you get 0.02 moles of we have obtained 0.02 moles of calcium carbonate, and those are the number of moles of calcium carbonate in 0.2 grams. Alright, we also want to try this 0.5 grams of calcium. So likewise, we shall use this. What's the relative atomic mass of calcium? It is 40. So 40 grams of calcium are contained in 1 mole. That one is the first statement that we are talking about. 40 grams are contained in 1 mole. What about the one we have 0.5? What about 0.5 grams of calcium? Calcium are contained in 0.5 times 1 divided by 40. 0.5 times 1 divided by 40, so we are getting moles. So in this case, what are we obtaining? So here we have 0.5 times 1 divided by 40, and our answer is 0.0125. These are moles of calcium. So we have obtained 0.0125 moles of calcium. So anyway, someone has to go through this, and you calculate 5 grams, the number of moles in 5 grams of sodium carbonate. Just know that when you calculate the RFM of sodium carbonate, the answer is 106. If you take sodium to be 23, carbon 12, and oxygen 16, you calculate, you get 162. If you go ahead to calculate, you will get the answer. Then also you can try out the one of maybe 5 grams of magnesium. Magnesium equals 24, so 5 grams of magnesium. and you give us the answer in the comment section. We shall read it. So this is the way how we can be able to convert the mass to moles. Next time when we appear, we shall look at converting moles back to mass, and that's what we shall look at in the first one. So the other one was lesson 1, whereby we looked at calculating relative formula mass. Now lesson 2, we have looked at converting mass to moles. What is your hardship? Where you haven't understood, please you reach us in the comment section. We shall be able to read what you haven't understood. So next time we shall convert moles back to mass. At this particular moment, allow us end here. We wish you the best.